Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from thermal properties of matter and kinetic theory of gases. Kinetic theory of gas chapter. Okay. A cup of coffee cools from 90 degrees to 80 degrees in T minutes when the room temperature is 20 degrees. The time taken by a similar cup of coffee to cool from 80 degrees to 60 degrees at a room temperature same at 20 degrees is. Okay, let us see what he gave. He told that he took a cup of coffee which is at a room temperature of 20 degrees. Okay, 20 degrees Celsius. Now what did he give? He told that he took a time t for the temperature of this coffee to decrease from 90 degrees to 80 degrees. Okay, this is one case. And in another case, he took the same cup of coffee and the room temperature is also 20 degrees. Now what did he say? He told that the temperature of the coffee fell from 80 degrees to 60 degrees Celsius. Okay. Now he is asking us to calculate time t dash for the temperature to fall from 80 degrees to 60 degrees. Okay. Now to solve this sum, let us use one shortcut. To understand this shortcut, you should know a concept. Okay. The concept is this. That is, this is the cooling curve of a body. That is, for every body, the temperature of the body falls with respect to time in this manner. Okay, that is, it falls exponentially. Okay, now if you see, the initial fall is more compared to the later fall. That is the thing happens is initially the body cools very fast compared to later. Okay, what is the reason? The reason is the temperature difference between the body and the surrounding. Okay, so what is that is greater the temperature difference between the body and the surrounding, greater will be the rate of cooling. That means initially the temperature difference between the body and the surrounding will be more, so the rate of cooling will be more, okay, compared to later. If you go to this case where the temperature difference between the body and the surrounding is less, then what will happen? The rate of cooling will also be less. Now let us use this concept or this logic to solve our sum. Okay, so now what did he give? He told that it took t time for the temperature of the coffee to decrease from 90 to 80 degrees. Now you have to calculate t dash, which is the time taken by the similar cup of coffee to decrease its temperature from 80 to 60 degrees. Okay, so 80 to 60 degrees. Now what will I do? I'll split this as 80 to 70 and from 70 to 60. Okay, now so it is clear that it took a time t for the cup of coffee to decrease, for the temperature of the coffee to decrease from 90 to 80. Okay, now when we start from 80 to 70, the temperature difference between the coffee and the surrounding is less compared to this case. That is it takes a time which is greater than t, that is t plus e. Now let us go from 70 to 60. Still the temperature difference between the coffee and the surrounding is still less. That means it takes more time than t plus e, that is t plus e dash. Now let us calculate the total time. The total time t dash will be equal to t plus e plus t plus e dash, that is equal to 2t plus e plus e dash. Okay, it is clear that t dash will be far greater than 2t. Okay, so now let us use this logic and try to eliminate the options. If you see this option, your t dash is 1.3 times that of t. So this option will not be correct. This is less than t. So this will also be wrong. Okay, this is also less than t. This is also less than t. So this is also wrong. Whereas if you see this, its value is greater than twice that of t. Okay, so the option is this option, that is first option. Now let us try to solve this sum in general way. Okay, to solve this sum, we'll use Newton's law of cooling. From Newton's law of cooling, we can write theta 2 minus theta 1 by t is equal to k into theta 1 plus theta 2 by 2 minus theta naught. Okay, theta naught, where theta 2 minus theta 1 is the temperature difference and theta 1 plus theta 2 by 2 is the mean temperature and theta naught is the room temperature and k is called as cooling constant and this depends upon surface area and the surrounding, and t is the time taken for the temperature to fall from theta 2 to theta 1. Okay, now let me take this as case 1, this as case 2. Let me use this formula for case 1 and case 2. Okay, the other point here you have to remember is in both cases k will be constant. The reason is he told that it is a similar cup of coffee and room temperature is also 20 degrees. Okay, so in both cases k will be constant. Now let me use this equation for case 1. Okay, when I use this equation for case 1, what will I get? Theta 2 minus theta 1, that is 90 minus 80. 10 by t is equal to k into theta 1 plus theta 2 by 2, that is 90 plus 80, 170 by 2 minus room temperature 20 degrees. Okay, now if you go for let me solve further, that is 10 by t is equal to k into 85 minus 20, that is 10 by t is equal to k into 65. Okay, now let us apply this equation for case 2. Okay, when I apply that, what will I get? Theta 2 minus theta 1, that is 80 minus 60, that is 20 by t dash, this t dash you have to calculate, is equal to k into theta 1 plus theta 2 by 2, that is 140 by 2 minus 20. Okay, that is 20 by t dash is equal to k into 70 minus 20, that is 20 by t dash is equal to k into 50. Okay, this will get cancelled. Let me take this as equation 1, this as equation 2. Okay, 1 by 2 will give me 10 by t whole divided by 2 by t dash is equal to 65 into k by 5 into k. Okay, this will get cancelled, this will get cancelled 13 times. Okay, this will be get cancelled by 5 times. Then if you solve this, you will get t dash as t dash is equal to 13 into t by 5. Okay, so which is option 1. Okay, now let us go to our next sum. Let us see first one. Root mean square speed of a gas is gas molecules is, it's a direct formula, that is root 3 RT by capital M. Okay, pressure exerted by ideal gas, that is 1/3 mn/c square. Okay, where m is the mass of each gas molecule, n is the number of gas molecules present per unit volume. Okay, next, average kinetic energy of a molecule. We know that the kinetic energy per molecule per degree of freedom is 1 by 2 kT, where T is absolute temperature. But he told that it's a molecule. So for molecule, you will have 3 degrees of freedom. Then the average kinetic energy will be 3 by 2 kT. Okay, next, the total internal energy of 1 mole of diatomic gas. Okay, we know that the total energy per molecule for 1 degree of freedom is 1 by 2 kT. Okay, that this is for molecule. Okay, one molecule. But if you consider 1 mole consists of n number of Avogadro number of molecules. Okay, then the total internal energy will be, or the total energy will be 1 by 2 N.K.T. That is equal to 1 by 2 RT. Okay, this is for 1 degree of freedom. Okay, 1 degree of freedom. But for diatomic gas has 5 degrees of freedom. Okay, 5 degrees of freedom. Then the total energy will be 5 times of 1 by 2 RT. That is equal to 5 by 2 RT. That is your R option. Okay, so finally the answer for this is your second option. That is A is Q, B is P, C is S, that is 3 by 2 KT, and D is R. Okay. If you feel that this video is useful, kindly share to your friends. And if you have any doubts, comment me in the comment section. Okay. The only thing that I expect you is a single like, because your single like will encourage me for making better videos. Okay. Thank you.